Assalamualaikum. This is a presentation for Bmip 2514 CAD CAM. Today, we will present our project titled Over Mounting Bracket, where we design the component using CATIA and develop the CAM project for CNC machining. I am NAZHIF, and I will be explaining it. CAD CAM first stand for Computer Aided Design and Computer Aided Manufacturing. CAM is used to create accurate 2D drawings and 3D models, while CAM converts these digital models into machining instructions that can be executed by CNC machines. By integrating CAD and CAM, manufacturers can improve productivity, reduce errors, and produce high-quality components more efficiently. The CNC machining plays an important role in modern manufacturing because it provides high precision, repeatability, and automation. It is widely used in industries such as automotive, aerospace, and medical manufacturing, where components require tight tolerance and consistent quality. Combining CNC machining with CAD-CAM technologies enables efficient production with minimal human error. The objectives of this project are to develop a 3D CAD model of the oval mounting bracket using CATIA, to prepare the CAM machining process, to select the suitable machining operation and cutting tools, and to stimulate the machining process and verify the generated tool path. The selected component for this project is an oval mounting bracket. It consists of an oval-shaped base, multiple mounting holes, a central slot, and rounding edges, making it suitable for demonstrating various machining operations such as facing, roughing, drilling, and profile contouring. The scope of this project covers the complete CAD and CAM workflow using CATIA, including modeling, machining, setup, tool selection, and tool path simulation, and also NC program generation. However, due to an unexpected breakdown of the assigned CNC milling machine, the project was limited to simulation and CAD programming, and the actual machining process could not be carried out. And that is all from me, and I will next pass it to my teammates.
Assalamualaikum and a good day. My name is Muhammad IZZUDDIN bin HAMDAN. Matrix number B1424210201. And I will be continuing with the presentation with the methodology. Our process is divided into phases to transition the oval mounting bracket from an engineering drawing into a fully verified manufacturing program. First, we perform a thorough engineering drawing analysis. We analyze the dimensions and tolerance to identify critical machining features, such as the central slots, fillets, and mounting holes, to determine our toolpath strategies. Next was CAD modeling in CATIA. We began with a 2D sketch, applied a pad operation for the base thickness, used pocketing, hole making, and edge fillet features to generate our exact 3D model. For CAM preparations, we configured a 3-axis machining process compatible with our 5-axis CNC environment. We defined the precise raw stock material boundaries and established a secure safety plane to prevent real-world tool collisions. Next, tool selection was highly specific to the geometry. 1 face mill for surface flatness, 2 separate end mills for heavy roughing and pocketing, 1 ball mill to handle complex 3D curved transitions smoothly, and finally 1 twist drill for the mounting holes. Finally, we established our machining operation sequence. We structured this logically, starting with facing, roughing, profile contouring, isoparametric surface finishing, and concluding with drilling and pocketing. We ran a full toolpath simulation in CATIA to validate the sequence and ensure zero tool or holder collisions. Once verified, we post-process the data to generate the final machine-ready NC G-code program. That is all from me. I will pass the presentation to the next member.
Okay, Assalamualaikum and very good evening. So my name is DANISH bin MUZAFAR. My matrix number is B14241017. So as for today, I will be presenting about the simulation regarding our selected design, which is oval mounting bracket. So for today, I'll first be talking about the finalized design for our 3D part. So after some reviewing and some discussion with the lecturers and our teammate, we have decided that this is our final product, and we have done the CAD drawing using the CATIA. So as reminder, the design design dimension must comply with the stock requirement, which is for the stock, it must be 150 millimeter over 100 millimeter, and by the height of 25 millimeter. So our part is 140 millimeter by 90 millimeter and the height of 24 millimeter. So there is a gap for machining process later. So as for the machining, there are two types for the machining. So at first, we'll be talking about the type of CAM process, and then for the tool that have been used for the CAM machining. So as for the type of CAM process, there are 6 processes that must be in this project. So at first, we'll be talking about the facing. And the second one is the roughing operation. And the third one is profile contouring. And the fourth one is isoparametric machining operation. And the fifth one is drilling operation. And the last one and the sixth one is pocketing operation. So these are our types of operation that must be concluded inside the CATIA CAM machining. So as for the tool, we has used the around 4 or 5 type of tool. The first one is a face mill, which is diameter 63 millimeter, and the second one is end mill, which is diameter 16 millimeter, and the third one is end mill, diameter 10, and the fourth one is a ball mill diameter 10, and the last one is a drill for diameter 8.5. Okay, for the simulation, after we have successfully conducting and editing each process for this CAM, so we can finally run the simulation perfectly and smoothly. So this is our successful generated simulation. So wait. Okay, simulation. Okay, just put from the start, and then we can run. So here is our operation. So for the operation is successful. So it very comply with our specification. So as for issues encountered, there are 3 types of issues that we are encountered. Okay, for the first one is difficulty on double work plane coordinate. So for this, we must use 2 work plane. So at the first, it was very difficult, but at the end of the time, we managed to successfully using the coding for the machining process. And the second one is wrong tool selection and operation. Okay, for these issues, at first we usually for using incorrect tool type, tool size, and tool type of operation. This cause can lead to the error in the machining process. But at the end of the day, we carefully examine all the type of tool size and the type of operation. So with the implementation of knowledge during this semester, so we finally managed to exceed with this program. The third one and the last one is the tool collision. So for these issues, when we encountered because we using the incorrect tool path, and there is no regret, so it can lead to the destructive path when conducting the machining. It is very not good. But at the end of the day, we managed to adding some regrets for the required operation. So we finally managed So that's all from me. Thank you. I will pass to the friend. Thank you.
Assalamualaikum and greeting. My name is Muhammad ZOLKARNAIN. So today I'm going to present about conclusion. The objective of this project were successfully achieved. We complete the 3D CAD model of the oval mounting bracket, prepare the CAM machine setup, successfully verify the machining simulator, and generate the NC program for CNC machining. This outcome demonstrates the complete digital manufacturing process using CATIA. However, our project had one main limitation. Due to the unexpected breakdown of the CNC milling machine, we were unable to perform the actual physical machining. Therefore, our work was limited to the design, programming, and simulation stage. Throughout this project, we gained valuable knowledge and practical experience. In CAD-CAM integration, we improve our understanding of machining process planning, cutting tool selection, tool path generation, simulation, and NC programming. We also enhance our problem solving skill by overcoming challenge encountered during the project. So that is all from me. Thank you. That concludes our presentation.